When designing electrical services for structures expected to settle, especially during construction, it's crucial to incorporate measures to accommodate this movement. Failure to do so can lead to stress on the conduit system, potential damage, and service interruptions. In the case of a 40-story building with an anticipated settlement of 4 to 5 inches, careful planning and specific installation practices are necessary. The primary concern is the rigid galvanized steel, or RGS, conduit that will house the 25 kV service conductors as they enter the building from the manhole. Since these conduits are installed within the slab foundation, any settlement will directly impact them. Firstly, consider using expansion fittings specifically designed for conduit systems. These fittings, also known as expansion deflection couplings, are designed to absorb movement in multiple directions, including axial, lateral, and angular displacement. They typically consist of a telescoping section that allows for expansion and contraction, accommodating settlement without putting undue stress on the conduit or its connections. Expansion fittings are available in various sizes and materials to match the RGS conduit being used and can be installed in the conduit run between the building and the manhole. The number and placement of expansion fittings should be determined based on the anticipated settlement and the length of the conduit run. Consult the manufacturer's specifications for the fitting to determine its allowable movement range and install accordingly. Secondly, introduce a flexible conduit section between the rigid conduit and the point of entry into the building. This flexible section can act as a buffer, absorbing some of the settlement movement. Options for flexible conduit include liquid-tight flexible metal conduit or liquid-tight flexible non-metallic conduit. The choice depends on the specific requirements of the installation, including voltage, environmental conditions, and local electrical codes. The length of the flexible conduit section should be sufficient to accommodate the anticipated settlement, but not so long that it creates excessive sag or strain. Support the flexible conduit properly to prevent damage or stress. Thirdly, ensure proper grounding and bonding of all conduit sections and fittings. Settlement can disrupt the continuity of the grounding path, which is essential for safety. Use grounding bushings and bonding jumpers to maintain a reliable ground connection throughout the conduit system, especially at expansion fittings and flexible conduit sections. Verify the grounding system's effectiveness after installation and periodically thereafter to ensure it remains intact. Fourthly, consider the bedding and backfill around the conduits. Proper compaction of the soil around the conduits can minimize differential settlement and reduce stress on the conduit system. Use appropriate backfill material that is free of large rocks or debris that could damage the conduits. Compact the backfill in layers to ensure uniform support. Fifthly, implement regular inspections of the conduit system during and after construction. Monitor the expansion fittings for any signs of overextension or compression. Check the flexible conduit sections for damage or excessive strain. Inspect the grounding and bonding connections to ensure they remain secure. Address any issues promptly to prevent further damage or service interruptions. Sixthly, collaborate closely with the structural engineer to understand the anticipated settlement profile and any potential variations. The structural engineer can provide valuable insights into the expected magnitude and direction of settlement, which can inform the design and installation of the conduit system. Share electrical design plans with the structural engineer to ensure that the conduit installation is compatible with the building's structural design and settlement mitigation measures. Seventhly, consult with the local electrical inspector and utility company to ensure that the proposed installation practices and materials comply with all applicable codes and regulations. Obtain necessary permits and approvals before commencing work. The electrical inspector can provide guidance on specific requirements for conduit installations in settling structures. Eighthly, use Schedule 80 RGS conduit instead of Schedule 40 RGS conduit for increased mechanical protection. Schedule 80 conduit has a thicker wall and higher strength than Schedule 40 conduit, making it more resistant to damage from settlement or other external forces. Although Schedule 80 conduit is more expensive, the added protection it provides can be worthwhile in situations where settlement is a concern. Ninthly, consider encasing the conduits in concrete. Concrete encasement provides additional support and protection for the conduits, helping to distribute the load and minimize stress. The concrete encasement should be designed to withstand the anticipated settlement and any other loads that may be imposed in the conduits. Consult with a structural engineer to determine the appropriate concrete mix design and reinforcement requirements. 10thly, utilize expansion joints in the concrete slab. If the conduits are embedded in a concrete slab, expansion joints should be installed in the slab to accommodate settlement. The expansion joints will allow the concrete to move without putting stress on the conduits. The location and spacing of expansion joints should be determined based on the anticipated settlement and the size of the slab. When using expansion fittings, ensure that they are properly installed and maintained. Follow the manufacturer's instructions for installation and lubrication. Inspect the fittings regularly for any signs of damage or wear. Replace the fittings as needed to ensure their continued effectiveness. Select expansion fittings that are compatible with the type of conduit being used. Ensure that the fittings are rated for the voltage and current of the electrical system. Choose fittings that are resistant to corrosion and other environmental factors. When using flexible conduit, ensure that it is properly supported. Use conduit clamps or straps to support the flexible conduit at regular intervals. Avoid overbending or kinking the flexible conduit, as this can damage it. Protect the flexible conduit from physical damage. When grounding and bonding the conduit system, use appropriate grounding bushings and bonding jumpers. Ensure that the grounding connections are tight and secure. Test the grounding system regularly to ensure its effectiveness. Document all installation practices and materials used. Keep detailed records of the location of expansion fittings, flexible conduit sections, and grounding connections. This documentation will be helpful for future inspections and maintenance. Regularly inspect the conduit system for any signs of damage or settlement. Look for cracks, bends, or other signs of stress in the conduits. Check the expansion fittings for any signs of overextension or compression. Monitor the flexible conduit sections for damage or excessive strain. Address any issues promptly to prevent further damage or service interruptions. In summary, accommodating building settlement in electrical service design requires a comprehensive approach that considers various factors, including the anticipated settlement, the type of conduit being used, and the local electrical codes. By implementing appropriate installation practices and materials, it is possible to ensure the long-term reliability and safety of the electrical infrastructure. Always consult with qualified professionals, including electrical engineers, structural engineers, and electrical inspectors to ensure that the design and installation meet all applicable requirements. Remember that settlement can also impact other utilities entering the building, such as water and gas lines. Coordinate with other trades to ensure that all utilities are properly accommodated for settlement. Consider using a building information modeling or BIM system to model the conduit system and simulate the effects of settlement. This can help to identify potential problems and optimize the design. Educate building owners and maintenance personnel about the importance of regular inspections and maintenance of the conduit system. Provide them with a written plan that outlines the inspection schedule and procedures. By taking these steps, it is possible to mitigate the risks associated with building settlement and ensure the safe and reliable operation of the electrical system. Furthermore, explore the use of articulated joints within the conduit run. These joints allow for controlled movement in specific directions, providing a degree of flexibility without compromising the structural integrity of the conduit system. The placement and type of articulated joint should be carefully engineered based on the anticipated settlement patterns. Consider using a slip joint design, which allows for axial movement while maintaining a watertight seal. Slip joints can be particularly useful in areas where significant vertical settlement is expected. Protect all exposed conduit sections from corrosion. Apply a protective coating to the conduit to prevent rust and other forms of corrosion. Regularly inspect the coating and repair any damage promptly. Use stainless steel conduit in areas where corrosion is a significant concern. Stainless steel is highly resistant to corrosion and can provide a longer lifespan in harsh environments. Ensure that all conduit supports are adequately sized and spaced. The support should be able to withstand the weight of the conduit and its contents, as well as any additional loads from settlement. Use adjustable supports to allow for fine-tuning of the conduit alignment as settlement occurs. Consider using a trenchless installation method for the conduit. Trenchless methods, such as horizontal directional drilling, can minimize disturbance to the soil and reduce the risk of settlement. These methods can also be faster and less expensive than traditional trenching. In addition to expansion fittings and flexible conduit, consider using expansion loops. Expansion loops are U-shaped sections of conduit that allow for expansion and contraction. They can be used to accommodate both axial and lateral movement. The size and number of expansion loops should be determined based on the anticipated settlement and the length of the conduit run. When installing conduit in concrete, use a non-shrink grout to fill any voids around the conduit. Non-shrink grout will prevent the concrete from cracking or spalling due to settlement. Avoid using dissimilar metals in the conduit system. Dissimilar metals can corrode when they come into contact with each other. Use compatible metals for all conduit sections, fittings, and supports. Consider using a cathodic protection system to protect the conduit from corrosion. Cathodic protection systems use an electric current to prevent corrosion. They can be particularly effective in areas where the soil is highly corrosive. Monitor the performance of the cathodic protection system regularly to ensure that it is working properly. Document all changes to the conduit system. Keep detailed records of any modifications, repairs, or replacements. This documentation will be helpful for future inspections and maintenance. Train building maintenance personnel on the proper inspection and maintenance procedures for the conduit system. Ensure that they understand the importance of regular inspections and prompt repairs. Encourage building owners to invest in a preventative maintenance program for the conduit system. Preventative maintenance can help to identify and address potential problems before they become major issues. By following these guidelines, it is possible to design and install a conduit system that can withstand the effects of building settlement and provide reliable electrical service for years to come. Remember to always prioritize safety and consult with qualified professionals to ensure that the installation meets all applicable codes and regulations. Finally, explore the use of flexible couplings with increased angular deflection capabilities. Standard flexible couplings may not provide sufficient flexibility to accommodate the anticipated settlement, especially if the settlement is uneven or occurs over a short distance. Couplings with increased angular deflection capabilities can provide a greater range of movement, reducing stress on the conduit system and minimizing the risk of damage. When selecting flexible couplings, ensure that they are rated for the voltage and current of the electrical system and that they are compatible with the type of conduit being used. Also, consider the environmental conditions in which the couplings will be installed, such as temperature, humidity, and exposure to chemicals or corrosive substances. Choose couplings that are resistant to these conditions to ensure long-term reliability.